Hello and welcome. I'm Bill Wake. We're here working on evolving a design. So we're taking our basic interpreter and we're trying to substitute out the parser. We wrote it with a recursive descent approach, and we have since then developed a parser combinator library, and we're just going to try and swap them out. Now, the core way we're doing that, we're looking for interoperability. So if the old can call the new and the new can call the old, then we can kind of replace pieces whenever we want. You know, whichever piece we want, we can just dive in somewhere and do it. If only one could call the other, it gets more complicated, and we're fortunately not in that situation. So we started off with we have our recursive descent parser, and then we call this thing we called wrap new, which wraps a new parser. And the idea is the wrap new is an adapter. It basically calls the new parser, but then returns the results the way the old recursive descent parser would. Now, I realized after we finished yesterday, like, oh, we don't really handle the error case the same. So we got a little bit of a to-do to make that happen. But the idea is we would wrap it so it could just plug into the recursive descent and we wouldn't care. Today, excuse me, we want to do the opposite wrapper. We want to be able to have our new parser call the wrapper of the old style, and that calls the recursive descent parser, and the results get translated into whatever the new parser wants. Okay, and you can see once we have that, we can call old and new at will and wrap wherever it's convenient. Or call wherever it's convenient, replace things one at a time, and in this approach where we're doing evolutionary design, I want to be able to kind of smoothly move from the original system to the new system, release as many times as I want in the middle. If I get interrupted for some reason, it's okay. I can come back to it. But we're not held up. We don't have all the parts lying out on the floor or anything like that. We have little tiny changes we can make. And that's kind of fundamental to this type of approach. It's not you don't always have that luxury. There are times where you can't wrap things properly and so on, but when you can, it all goes very smoothly, and it's a nice way to get a big change in. Okay, let's go to the IDE. Alrighty. So some tasks for today. One is I'd like to get a new style parser for the dim statement. And to do that, it has to call the old parser for the dimension info, which is like I don't know if it's the name and size of the array or whatever it is, but the dimensions. And then we'd have an excuse, in effect, to write a wrapper for the old parser. So we can create the new dim statement. It calls the wrapper, and then it just works. Then we've crossed the line. We got two-way compatibility. Now, unfortunately, like I said, we didn't quite conform. We broke the first rule of adapters, which is provide the same interface. Okay, so my error handling is a little different. We'll deal with that. I also want to add some tests back in, and we have some refactoring we can do around tokens and so on. So I think we'll do those things. Let's see. These comments here were more for the interpreter, so I'm going to move it down to the earlier project so we don't get distracted with it. Okay, and today's episode 2. All right. I would, well, in a way, I feel like these pieces are more they're more critical for the long run success. That I would really feel better if everything was tested through and compatible and all that stuff. But I feel like I'm kind of like trying to. It's kind of like a spike, but it's not throwaway code or anything like that. It's I'm just trying to make sure the pieces are there that we can do the whole process. And these I think of as like obligations I spun off for myself. I need to do them at some point, but they don't necessarily have to come first. What we have works. It's just that it's not consistent with the rest of the solution. Okay. So dim. let's see. I think, well, we'll want the parser for sure. Oh, no, we don't for sure. Syntax analyzer, we renamed it. Okay, and I'm just going to try and close out some of the stuff that's not so relevant. Okay, so let's find the dim statement. I'm pretty sure it's like this. Yeah. Okay, so dim is you say something like dim a3 comma 5, and it says I want an array called a. It ranges from 0 to 3 and 0 to 5. They're not strictly 0 based, not strictly 1 based. Okay, so it's really a 4 by 6 array. That's basic for you. Okay. And so the recursive descent routine for this is call next token to skip past the dim, and then I'm going to build up these dim infos. You can see that we have dim info we call dim1, which gets a dim info, and we call dim1 again separated by commas. So that's that separated by loop that's pretty awkward in recursive descent. You end up calling the same thing twice, but we have an operator for it in our parser combinator. So it'll make a nice change there. Okay, now this is interesting. It does produce errors, dim info. All right, but dim info, this dim1 thing, I don't know. Can I name that dim info? I named the variable that. I don't know if it'll make a conflict. No, good. Okay. Well, let's run tests and make sure. Whoops. Cannot call value of non-function type dim info. Okay. Apparently I can't. Perhaps I went through that the first time. I don't know. Okay. Well, I can rename this to info and try again. Cannot call function. Cannot call value. Type capital D dim info. How weird. Cannot call value. I don't know. Oh, whoops. Control C, Control C. Okay. All right. So, this replacement. Well, let's drive this one in. Okay. We want something that is a parser in our parser combinator sense. Let's see. I can probably bring that class back that I closed so anxiously. Okay. We need to define a parser, which means it's got to have this method that takes array slice and returns these. We want that. Our wrapper is going to have to be like that. So let's put a test in. Yeah, I think we can. We can probably test this. Okay. So I'm going to put it up here with these others. All right. The wrapper stuff's going to go away, but we'll get there. Whoops. That's another helper. Okay. So what I want to say is well, let's look at our new wrapper. That's all the way up top. Come on. Wrap new. Okay, parse this. Yeah, I think we're going to make a class wrap old. We're going to initialize it with a method, and um, the method, in our case, will be dim info. So let's do something like that. So let let's say parser equals wrap old, and then we would like to wrap well, I want to call dim info, but I got to get one first. So let analyzer equals syntax analyzer. Okay. And this is analyzer.diminfo. Now, our parser, we're going to call, we may have to do some stuff, but we're going to call parse on it and get a parse result and check that it's the right kind. Okay, so let result equal parse result. Sorry, equals parser.parse, and dim info starts at the variable. Let's make sure that's true. Yeah, it starts at the variable. Okay. Okay, so that would be perfectly legitimate there. I don't know if it'll. We need a slice. We might have to do a little more work to get it, but okay. So if you parse that thing, if case let, well, let's go the other way. Guard case let blanking out how to do these. I think it's like this. Guard case dot success let value let remaining equal result else xct fail, and let's give it a message. Let's just pass the result back, and I think we have to return. It doesn't know that xct fail will get it out of there. Okay, so now we got the value. I'm hoping value is a dim info of A. Oh, come on. You don't want to tell me this stuff. Okay. Parse dim info. Dimensions is an array with a number 2. It might be a 3. I'm not quite sure if it's the count or the upper value. And I think a type. Right? Okay. Type dot number. It's a numeric array. Okay, so that's what we expect there. And let's put the comma as if we were doing more. We're only going to parse the first one. B3. Okay, and then assert equal. So our remaining, should be comma, B3, I think. We may, again, I'm not quite sure I got the types right, but we're getting close. Okay. Ambiguous without more context, sure. Okay. Grab an analyzer, wrap the dim info method, call parse on it, feeding in an input stream, gets a value back, look at the value, the remaining, fail if they're not there, and make sure they have the right values. Okay. Yeah, that feels about right. Okay, so let's get wrap old. Okay, so wrap old is a class. And it's a parser. And I'm just going to look at one of these just to kind of make sure I'm defining it correctly. Okay, I'm going to have to give a type here. Oh, this will be interesting. I'm not sure. Okay, well, it'll need something. So it needs two stubs, and then it needs a parse. And I think this is going to have to be over my dim1 type. Okay. Which I've lost again. Okay. So dim1, well, the input type is tokens. It's really just a void method, right? So it produces this, so that's the value. So we'll need that for sure. 760. Okay, over value. Okay, input, well, target is value. I may be able to say input equals token for now, because I think that's what you're feeding in. Okay. Does not conform, add stubs. Yes. Oh, no. Public parse. Okay, good. Okay, since we're going to be a new style parser, we have to have these three things because that's what our protocol demands. Okay, and I don't mind hard coding token because these adapters are going away. I don't have to make it totally generic. Okay, so we pass in an array of tokens, and we get a parse result of token value. Token being the input type and value being the output type. And we need an initializer, init, and it's going to take an old parser of type void void throws goes to value. Okay, I think we could say all our old parsers have that form. Some of them return expressions, some of them return dim info, but they have that general form. No arguments going in, they might throw, and they return a value. All right, and then the code here, I don't know if I can value dot self. Is that no type? I'm gonna cheat for a moment. I'm gonna say it returns a value optional. And return nil. And just see if I can get things compiling this way. Compatible with token. Oh, returns success nil empty string. Is that going to work? Empty array. Oh, my test is not going to work. Syntax analyze parser tests. Let's put this deck here. Parser tests. Okay. This remaining is tokens. So let's just put well, this should be dot comma. I'm going to take out some stuff. Okay. If I call parser.parse, I need tokens. Ugh. I guess I can make an array of tokens. It cannot conform to equatable. Well, I think that's because this is not right. Syntax analyzer has no dim info. I think we're still, maybe we're not quite built. Oh, this was so clear and easy in my head. Okay, let's make this the array. Token dot. Oh man, I don't want to do all this work. Yes, I really don't want to do this work. Maybe this test is too big a bite for now. Oh, I don't have, no, I do have to care. Oh, I don't have to care. All right, let's simplify. Let's not use this. Let's make our own test. Okay, so let's make a function. It's match plus. This, it returns a string. Does it return? Let's make it return a character. Okay, because my parser, the combinator parser doesn't care what it's looking at. It's all parameterized. So we can make this. Let's do plus comma dot array of that. Okay, so I'm taking the string, I'm turning it into an array, which is also an array slice, I think. I may have to do some fiddling with that. But I'm going to wrap old with match plus, the method. Okay, and I don't need the syntax analyzer now. Parse array that cannot convert to array slice. Okay, I think I can do this to get a slice of the whole array. Oh. Now a minute ago you were all over it, so what's your problem? Cannot convert array string.element, array of character, to expected type, array slice of token. Oh. I wasn't as generic. Okay, let's go back here. We'll wrap. Let's wrap the type. Let it be implicit. Okay, so we'll wrap an input type and a value type. Bold does not conform to parser. Do you want to add stubs? Parse result input target. Okay, let's do a build. Wrap all does not conform. Add value stubs. Oh. Parse result in value. Okay, build failed, but it's on the test. Right. Cannot convert array to array slice. No. Wrap old in. Oops. Type is character. Okay. Are you happy? Can I convert value array slice character? Okay. I'll get there. Okay, we're getting closer. All right. Now our value should be the first character plus, and the remaining should be a comma. Let's see, the type, array literal element, comma, has the member, comma. I think it's a little behind. Missing return here. Okay, yes. Now, where's the input coming from? Parse array. So this is an old style parser. If input.first is plus, return it. Else throw new. Well, let's just return junk for now. Okay, so we'll ignore the failure results. Oh, getting that first test. And okay, let's see. So we're wrapping an old style parser, and this thing. Oh, I still need the syntax analyzer. To make sure the parser, it has to deal with the token inputs. Okay. How can I? Let's see what do we have something? Okay, require variable conforms to our thing. It consumes, it throws, and it returns a type. Okay, so we can use that one. It's a simple one. All right. Let's take this out. I'm going around in circles. I know. Okay. Let analyzer equals syntax analyzer. Okay. Wrap the old. We'll let it see if it can infer this stuff. Analyzer.require variable. Parse. We need to pass in an array of a slice of tokens. Let's pass in a token.variable. Yes, token variable. Where's my token? Okay. Oh, I have to do all that stuff. Let's find a token test. So we've been relying on the Lexer to produce these things. Okay. Yay. I just want to get through the test. Okay. Let's. Okay. X comma. All right. And when you. Okay. We got 2 tokens going in. We're parsing with that. Okay. The result type is string. I guess I inferred that from the method. But the input type is token. Have I got them in the right order? Input type is token, value type. Okay. Yeah. Okay, we got this method. We call the Elixir, get the X, get the comma, pass those into the parser. We check these. Okay, the output. Let's see, the string should be the variable X, and the remaining should be token 2. It might have to turn into a slice, but hopefully not. Okay. I think it will convert arrays to slices under at least some circumstances. I'm never quite sure when it needs that ... notation. Okay. How's this? Start with syntax analyzer. Wrap its require variable function. Get some tokens. I'm using the Elixir because a token is a moderately complicated structure. I mean, it's got the line number, the column number. You know, it's got more information than I want to type than this. Because we need more than just the type of the thing. We need the whole thing. Okay. Value is not X. It should be a it should be a string. Yeah, I guess that is the string, right? That's what the require variable is producing. Variable produces a string, which is the variable name. Okay, coming from the token. So, yeah, it saved us from doing a little bit of stuff. Okay. Check the X, and we should still have a stream of tokens with the remaining tokens that we didn't need. Good. Okay. Now, this it's complaining. What's the matter? Type wrap all does not conform. Do you want to add stubs? Yeah, I think the only problem is this. Is that right? Nil is not compatible. Oh, yeah. I did do that. How do I fail? See, that's the problem with these generic types. It's a little tricky to set up these fake results. Now I thought there was a way to get like value dot view, so that's just not. No. Okay. I'm just gonna have to call this thing. Ugh. Okay. Let's call the old parser dot I always forget that word. Now this, I'm surprised it's not complaining about throws here. Do this. Return this. I'm purposely being something wrong. Catch and return dot failure -1 wrong message. Okay. Again, I'm just kind of trying to stub some stuff out here. Okay. Okay. I didn't expect to spend quite half an hour on this, but here we are. All right. Top to bottom. We got an analyzer. We wrap the old require variable function, input token, output string. We feed in a lexer x comma, token 1, token 2. Should be variable x and dot comma. And then we fetch the result. We say if you're not a success, then it's a fail. And if you are a success, your value should be x, the string value of that token. The remaining should be the rest of tokens. And then in here, I've tried to do stuff a little bit wrong, and this part will fail. I think this part will succeed. Okay. And let's run it. Okay. We got a failure. Well, yeah. Okay. I wasn't expecting that, was I? Why would it be a failure? Well, the reason is the old parser assumes tokens and all that stuff is set up. I hate to reach inside. I don't see a way around that. Okay, let's do analyzer.tokens equals this, and analyzer.index equals let's make sure how we start. -1. Yeah. Where's our parse? Yeah, we start index -1. So we're faking this part. Actually, this whole part. And we need token. Well, let's set it to 0 and analyzer.token equals token1. Okay. Again, I mean, I'm trying to set things up so it's like the other. I think there's some goofiness in there we need to address, but I'm willing to commit a little extra sins for a wrapper that's going to be thrown away. Yeah. Okay. The parse token1, token2 thing is correct because when it runs against that whole list. Okay. And maybe I should say analyzer.tokens to be more clear. That's what it's going to be doing in real life. Okay. Huh. So it's happy with constants. All right, well, let's leave it a constant then. Okay, let's run this again. Like Ted Young says, you got to make sure you get the right failure. Okay. Yay. Okay. Yeah, that's the failure I was originally expecting. It came back empty, even though we were expecting a token 2. Notice it got column 1, and it defaulted the line number, and it's got the comma. Okay, cool. Oh. And let's get things working. Okay. Now, what has to happen? No. Okay. All right, we've saved our old parser. That seems like what we need to do there. The parse, we're going to try old parser. Now, if it's success, well, this is input. We don't want to return an empty array. We want to oh dear. We want to get the index from the analyzer. So maybe we need the analyzer as well as the thing, because I need to know that this thing has bumped the index forward, and the rest of the input is really the slice of tokens. So I'm gonna add that. I don't see a way around it. Yeah. There might be, maybe I could nest the classes and stuff, but I think it won't hurt to be explicit that we're depending on the analyzer. Okay, so let's make analyzer of syntax analyzer. And we'll store the analyzer too. Okay. All right. And then this is really input sub analyzer dot index dot 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 dot. Okay, so it's saying take the slice of the array starting at analyzer. Starting at index. Okay, so when old parser finishes, it is going to have updated index to wherever, the next character after. Okay, and we're going to take the slice starting there. So since it's pointing at the character after, that should be the right place to slice. Okay, and I think that's okay. All right, so let's try this again. I'm hoping we get the right slice. Oh, no. Oh, yeah, we forgot that. Analyzer require variable. Okay, a long way to get to this result, but I think we're okay. We've returned the right rest of stuff. Okay. All right, now next test case. We got the old failure. It's going to be somewhat similar. Wrap old failure. Okay, so instead of, we just want to have a wrong input. Token 1, token 2, it's looking for a variable. It's not going to find it. We're passing in these two tokens, starting place. Okay. And then guard, we want to see failure, let index, and let message. And the index should be 0. And the message, should be whatever require variable does. Variable is required. Okay. Get an analyzer, wrap the require variable method, feed in a couple tokens, check that it is a failure. If it is, it should have an index, the point at which it failed, right at the start, and a message. Okay, this test should fail. Whoops. Okay, -1 and wrong message. Okay, yeah. I should have said, but that's what I expected. So easy to believe that now, isn't it? Okay, but we did hard code them, so I think I had a chance of getting it right. Okay, so now what happens? Well, if you get a parser error, let's see, you're throwing a parse error. Okay, so let's capture this. Oh, he's token. Oh. Okay. Well. I don't think that changes a lot, but cast parse error. think we say let token, let message. Okay. And then the failure, we need the column of the token and the message. Okay, and then what if something else goes wrong? This is kind of a not a can't happen. It's an unknown exception type. Let's do this for now. We're just trying to get through the compiler. Parser test variable is required. Okay, so I believe this should pass now. Okay. And then the other case, yeah, I'm not fond of this required throws. I guess I understand the reason, but felt like Java kind of made a mistake with that, and I don't think Swift is. All right, we need a third case, I guess. I don't see a way around that. Okay, so we got a syntax analyzer. Instead of require variable, I don't know if I can do this. Throws error forced. Can I do that? Can I convert value to closure type string? But I made that a throws, right? Throws. Oh, throw. Is that gonna work? Error cannot be constructed. Let's do I have to make my own error? See, it's kind of the worst, right? Because like in Java, at least I would say throws parser error, and it would know I'm not going to be throwing other kinds of errors, and it would just let it go. But catch unexpected error. Can I just say throw? I don't know. Are there standard errors that I can steal one? And there. That's probably the banking Swift standard. Yeah, I mean, I'll get an error there. Is that a standard thing? Still not happy. Cannot find division error. They defined it. Okay, what if I say nil sub 0? Is it gonna let me? No. Okay. Well, let's do this. Can I do that? Okay. That's something that will cause an access exception. Do I need the tokens? I don't think I do. I don't even think I need any going in, because I've got something that's going to fail on anything. Okay. Guard case failure. It should be index. I guess 0 is okay. And then unknown exception, maybe. Okay. I think this will fail, hopefully for the right reasons. It has no choice but to fail because we hard-coded the results. Okay. Oh, it's too fatal. It won't throw an exception for that. Oh. I don't know. Where's my parsers? Are they in here? It really is a can't happen, right? I mean, there's no... maybe I'm okay, just... I think I'm satisfying the compiler on a situation that won't really occur. Okay, so I'm going to take the test out because I don't think it can occur. The only type exception we throw is this parser exception. Okay, now let's run these tests. All right. So I think we have tested our old parser. Let's commit that. Add wrap old with its tests. And we're ready to apply it. Okay. So I think it's gonna do the job. Let's see, where's syntax analyzer? Okay. Rappled. It's a little awkward. I have to pass the analyzer, but we'll survive. We don't have access to the input stream otherwise. Okay. Our testing was a little goofy, but like I said, this test will go away in the end, so I think we'll just live with it. All right. Well, that's probably makes it a good time for a break. So we'll take a break, a 3-minute break, and then we'll come back and go back where we started, which was that dim statement. Find dim. Whoops. All right, we'll go back and try and make our dim parser, make a new style parser that calls the dim one and wraps that. All right, so see you in a few minutes. Welcome back. All right, so we're gonna take a go at dim here, and the dim statement, recall, is just dim, and then dim infos separated by commas. Okay, so it's dim. Um, Dim, then dim info separated by comma. Okay, yeah, I think that makes sense. All right, so let's go to statement. I think that's up here somewhere. Okay, so our dim parser, let's see, we need to do let dim, I'm going to say dim statement. We'll clean these up once we get the old ones out. It should be, well, we need to match a dim. We don't care about the dim itself, so we use this operator that throws away the left-hand side. But what it gets back, what it needs next, is a dim info, or dim one. Wrap old dim one is a parser, and then it is separated by comma. I think that's the way we want to say it. All right, so it's a dim statement. We haven't defined match yet. It's a dim statement. It's a dim keyword followed by one or more dim ones separated by commas. Okay. And then match is, it's another satisfy style function. Let's see. And again, I think we'll test this in a moment, but it's going to take a token of type, well, it's really a token type. Produces a satisfy token parser, and the result is satisfy where $0.type equals token type. Okay, so we're just matching the type field on the token. Okay, and this one, oh, cannot convert type throws to dim info to expected type syntax. Oh, yeah, we forgot. Self. Dim statement was never used. Okay, good sign. All right, now This is where I'm going to pay for stuff. We tried our one-word statements. Let's try our dim statement. So do the same sort of thing. The statement I don't know if I can reuse the name. New index equals. We got to wrap new dim statement dot parse token subindex. Okay. Invalid record. Yeah. I'm going to reuse them for now. Okay. And then I have to do the same kind of thing here. And we left out a piece, so we'll get to that in a minute too. So if the statement is not nil, then we adjust our indexes and stuff and we return the statement. Okay, the problem is, yeah, these messages from the combinator stuff are really unfortunate. It's like you get this horrible thing and it says, oh, let me simplify it for you. It's really just an optional blah, 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 you know. Ugh. All right. I mean, it's lovely looking, but ugh. Okay, the problem is the result of this is it's a parser basically, and then keep right is a parser, but we don't want a parser, we want a statement. Okay, so just like we had simple statement here, we need something that builds a statement from the dim info. Okay, and the result of this, okay, so we threw away the match of dim because it's a keyword, we know what statement we're in now. Wrap old with this, because it doesn't keep the comma either, it's just going to return an array of dim infos. Okay, and we need a, I'm going to say make dim. Okay, and that should be a function just like simple statement's a function. Okay, and not too much harder either. Make dim, and it gets in dim infos of array of dim info, and it produces a statement, and the statement it produces is dot dim with the dim infos, and that's it. Okay, I might even inline that. $0. When they're just so simple. I'm $0. Okay. Are you gonna build? Yes. Okay. So now that builds. This is okay. If it matched the dim statement, we return it. Okay. And if we got here, well, let's just put print can't happen for now. Can't happen. Okay. Assuming our dim statement does the job. All right. Now, I think all the pieces are there. So all that setup, right? Let's let it rip. Okay, that's how we like things to go. Instead of the hour of setup, but now's the payoff. Okay, and the payoff is any statement should be about this hard. All right, we've we've dealt with wrap old. Takes care of those dims. So now this can't happen. So let's take that out and let's find that dim method. Nobody should be calling this anymore. There could be a test out there that tests it directly. But yeah, there's no real uses. Okay. And so you compare this, what, 74 to 90 is 16, 17 lines. Okay. And that became kind of one long line or two lines, how you count it, in our new style. So it's definitely simpler. All right. We still have dim 1. Let's make sure that, oh, I didn't check that in. We will do that. Oh, okay. There's your answer. What? Okay, let's go back. Run these tests again. Did I miss a can't happen? Okay, the tests all going to pass. Can I search in here? Oh, interesting. Dim array tests. All right, let's go find those. Okay, they're a little different. And this may be dim a sub 2. All right, let's. So interpreter tests, that's confusing to me that would have anything. Oh, there they are. Dim knows type and size for multiple arrays. All right, let's break here. Sure enough. Okay, why did that not? So what that says is this did not match properly. Okay. Okay, so we get the program. We interpret the program. Interpreter.run. Okay, so interpreter program. He parses. Run. Okay, step parse stats. Oh, is that parser.parse line? Okay, let's stop here. Let's print tokens. Okay, line 10, dim a, parend, integer, parend, comma b, and so on. Well, that looks plausible. Now these are definitely harder to debug too. Let's break here. And the first parse doesn't count, right? Because we run through looking for data statements. But the second one, okay, here's the real one. Okay, parse line. Let's print line. Should be the dim. Okay, 10 dim. Okay. Now I'm going to continue here. Let's step in. Parse input. Okay, let's step in. This is the pipe. Dim. And then keep right. Okay. That should be no problem. Result 1 matched the dim. Okay. Now we got to go to the parse 2. Oh, this is tedious. Separated by keep left. Okay. This is keep left. Okay, I'm going to step out and over and look at result 2. Result 2 is a token array of dim infos. Oh, and it's a failure. It's trying to return array of dim info, so that's a good thing. Let's see what the message is. Variable is required. We missed an index somewhere then. So that was our and then keep left. So index 0. Sorry, the position is 2 with the line number. I mean, that looks like a variable at slot 2. Okay, let's... Oh, I hate being lost. Okay, let's look at our match. Could satisfy. Make sure it moves forward. Yes. Well, this is definitely making me wonder how we can debug these a little better. So it looks to me like the match should have dealt with the dim. We matched the dim. Let's make sure we got everything dim was doing. We try dim 1. We accumulate the info. We get the comma. We skip over it. We do dim info and append the results and then build it. So this is where you can see when we talk about the recursive descent style, we're doing the parsing, like match dim 1, match the comma. We're also doing construction of the result in this stuff. And we just did the little method at the end in the combinator parser, which is nice, but I don't think there's anything else going on in here. It skips past the dim. It immediately calls dim 1, and that's what we've done. We skip past the dim. We call dim 1. Okay. Okay, so this 2 to me seems okay. Can we tell the input? 1, 2. So this is a slice. It's starting at 1. There's the dim. It is looking for position 2. And a string variable is required. This sure looks like... Sorry, a variable is required. That's what this looks like. It has the string A. Yeah, that was the dim array test, had an A. I'm not sure what to do other than trace in again. Can we... Excuse me. All right, maybe we can do this as a test case ourselves. Maybe that would be a smaller bite. Parser test. Dim a sub 5, dim string, multidimensional, multiple arrays. Well, that looks a lot like what we're doing here. Dim a2, b1. I mean, this z thing looks more complicated. Let's make sure it's not. Wait a minute, why aren't you... Test dim with multiple arrays. Running all the tests. Why aren't you marked? We'll just continue. There it is. Okay. Do you get a can't happen? Yes, you do. Okay. That's a better place to start testing. All right, one statement. Dim z. Let's simplify it momentarily. See if it still gets a can't happen. Oh, well, that's going to be screwed up, isn't it? Two, three, four. How come you... Let's stop in dim 1. Okay. We'll see what we got for tokens. Integer dim, variable z, left paren, and so on. Okay, and what's our index? And what's our token? Our index is 1. Our token is the dim. We didn't get past that. We didn't consume the dim. Right, because token is supposed to be a wrap hold. Okay, and we parse. This is the wrap old. It's taking the input slice where it is. It's not. It's like we're not picking up. Okay, we got analyzer.index. So the remaining seems like it's correct for us. But I'm wondering if the starting point is right. So when the new parser runs, it doesn't adjust token. I think what's happening. Boy. Okay. I think what's happening is the new parser runs first to match dim, and it matches it. It's at the beginning slot. It says the remaining input should go to the next parser, which it does here, input, but we haven't moved the syntax analyzer's index forward to the array slices position, I think. And I think my test was too primitive, maybe. Okay, wrap old success, wrap old failure. Okay, we want wrap old success. Yeah, because I think because we're starting at position 0 when we look for that um, variable. I'm not sure right way to get this going then, because I think it's an interaction between the old and the new is the problem. So the new parser doesn't move the index forward. It only deals with slices. And so we kind of need to simulate the fact that the old one that it's done its job. Now, so I want to force the lexer parse token 1, token 2. Yeah, okay, I think I can do it. If I do this, Um, okay, let's put these three things in. The index is 0. The token is token 1. Okay, so that simulates if token 1 consumed the plus, and then this thing wants to slice. We should pass in a slice, not the whole array. Token 3 sub 1 dot dot dot. Okay. I think this test is going to fail. So we're saying plus x comma. We're parsing from 1 forward, token 2 forward. So it really should start running the old parser here at x. I don't think it's going to. Do I have any weird remaining? Should be token 3. Okay. All right. So in effect, the 0, the index here is, let's say we got a new style parser that's going to match the x. It starts at 0. It's fine. And it says, hey, your remaining is 1 dot dot dot. Okay. So I believe this will fail. Yay. Okay. Failed variables required. Okay. That's the kind of message we're getting on our other thing. Okay. So, what has to happen, I believe. And I don't know if we can screw this up any. I mean, I think input is always going to be the slice of the whole tokens array. Okay, but we want to force the index input.startIndex, and then token equals, this is analyzer, token equals analyzer dot, sorry, index analyzer dot token sub analyzer dot index. Grabbing around that analyzer. Ugh. Okay. But I think this is more what we need. The index needs to be moved forward to wherever the slice says we should start. Okay, so even if we've done new style up till now, we need to do a real one. And the token always corresponds to that. Okay, let's try that. This should work. Okay. Wait. Test right. Unknown statement. That. I'm going to accept message changes. I would like it to do that. But we may have to, okay, I'm not running the test. Wait a minute. Oh, my wrapper test passed. This one failed. Okay. All right. This is an error case. That's more likely to me. Okay, so I think at the point this was called, it returned. Let's see, where's the old? Yeah, old parser came back through an exception. Probably was that message that it's complaining about, missing right parend. We returned it, but notice the way we use the wrapper. Let's see, wrap old. So down in statement, this is where we're paying for my handling of the other error. Okay, we only check for statement not nil or not. If it's nil, that means this thing did not succeed in parsing. And so there was an error in the thing, and we just fall through. I don't know why we didn't get a can't happen. Unknown statement. Oh, we didn't restore state. Okay, let's look at our error case here again. Okay. Yeah. Okay. So I think what's going on is it actually parsed past the dim. This modified the real parser, and then when it picked up, so the new parser tried to match dim whatever, it failed after the dim. It had already updated the analyzer to point past the dim, and then when it failed, it left it there. Instead of a pure failure in the new parser is supposed to be nothing, the index, no index changed. Okay. Is this test enough? I don't know. Maybe it'd be better to make the old parser test do its thing. Okay, let's check that. What's up here? Okay. Wrap old success. Let's wrap old failure. Okay, so this is calling require variable. Let's do the same kind of thing here. And simulate a partial match from the a new style. Okay, so this is equals. So we're going to pretend we've matched the equals by saying start at 1 dot dot dot. Okay, so position 1 is the comma. Token 1, 2, 3, 0. Token is token 1. Okay. And we're expecting variable is required. Index should be 1. Okay. Let's see if this works. Okay. So that part's okay. How do I simulate this coming back? This is wrap old, right? So I should be doing more assertions. I should be saying assert equal analyzer.index should be restored to 0. Okay. And token analyzer.token should be restored to token 1. Okay, let's make sure that's the case. I think that part will fail. Yep. Okay, 1 is not equal to 0, and token column 1 versus column 0. Okay. Yeah. Now, in here. Okay, so what we need to do is save it. Let old index equal analyzer.index. Okay. And if we get back here, then we got to restore it back. Old index and analyzer.token equals this, and okay. I think we can do better than this thing. We can work the way that changes some too. And then this should happen here, even though it's kind of a can't happen case. Let's just be consistent. Okay. It's annoying, but I think it's what has to happen. Okay, so test wrap. This should pass now. This should pass without calling can't happen. Oh, still called can't happen. Oh, that one may be okay. Yeah, so now what happens is we attempt to parse it with the new parser. It fails with missing parend. We just look at the nil or not. Let's get down here. Okay, so down here we try dim statement. If it's nil, that means it didn't fully parse. So we say, oh, there was a syntax error, fall through. And then we end up calling dim, and it tries again, and it succeeds in getting the error message that we didn't see up there. Okay. All right, but we're back to a somewhat stable point. Not quite ready to get rid of dim. All right. Fix error in wrap old needs to restore analyzer index when a failure occurs. Okay, so where we are is dim on a successful call. It goes through the new parser. On a failure case, it goes through the new parser, finds an error message, says I can't build a statement, and then it tries again with the old parser, which handles the error. Okay. What do I want to do? Well, I think we're to the point of saying like, hey, this wrap new is not a true adapter because it's using a different error style. And I think that's what we need to fix next. It bugs me. Okay, maybe there's one more thing we can fix. I'm bugged by this token variable too. Okay. Let's see. That's part of syntax analyzer. Token, basically, when you access token, you are always accessing token subindex. And every time we change index, we update token. Okay, so let's find token equals. background token, error token, token equals, that's equals token sub index. Yeah, so it's holding there. Index, token sub index, save token. Okay. Yeah. So it's doing that every time. Which tells me it's sort of a function of these two things, and the relationship we're maintaining, we're the ones going out of the way to make sure that gets updated every time. So Swift has a way to do this, and I don't know if I remember the syntax, but I think we can just say tokens subindex. Okay, and I'm gonna, it's partly experimental at this point. Okay, and now the token equals stuff, I think that should be no longer necessary. Cannot assign, it's read only. Yep. Okay. Token equals, cannot assign, it's read only. Okay. Notice they are all holding that position thing. And then up here where we were doing this, now we don't have to do this anymore. Okay, so let's update to do. Make new parser for dim, calling behold old parser. Make wrap new. Okay, so what we did was introduce, make wrap old that calls old parser. That we've actually done. Okay, we sort of working on the new parser, but we're taking a diversion. Let's make token a read-only property. Okay, and I believe we've, okay, good. This should all pass. Okay, we missed a couple. Analyzer.token equals token 1. Yeah, that should be okay. And then this one again, yeah, that token 1 was index sub 0, so the relationship is holding. Okay, we still have some can't happens coming out from our dim, but we've successfully done this. Let's see, what do we got for can't happens? Can't happen. Oh, I keep doing that. Only once, right? Print error and dim. Okay, good. Let's get rid of these commented lines. Well, these commented lines. Okay, so to me, this is getting rid of something that's like, it would be easy to forget to do these updates, and the relationship always holds. So this is the right thing. Oops, analyzer. I think we look for token equals. That one's okay. That one's okay. Okay, wrap it around. Good. Okay. Make token a read-only property. small change, but I think it takes away a chance to make certain kinds of errors. All right, let's go back up. Oh, I probably left a little comment in up here. Yep. Okay. All right, now to do. We've done that. Whoops. Okay, new parser for dim. Make wrap new throw error. Like, yeah, I think that's. Let's just say test wrap new because we did already test wrap old. All right, make Alexa provide line to token. Well, that's another simple one. Yeah, okay. So maybe this goes together. Let's move this one down. We're going I'll just say error handling because we got the base case right. Okay. Make wrap new throw an error and test wrap new. They kind of go together. Okay, so let's look at wrap new. All right, so we did this thing where you return a nil if it fails. But really, the parser, sorry, we're supposed to make a new style parser, this kind of parser, look like an old style recursive descent parser. And I don't know why we have a parse method like this. This is a new style parser acting like a recursive descent. It should be throwing. It should return something and have a throws. Okay, so let's find our wrap new in use. Okay, I'm gonna say this thing should pretend it can throw. I don't know if it'll whine a little bit here. Like, you don't really throw yet. Okay. But we call parse. Okay, no calls to throwing functions. It's just a warning. Okay. But let's treat this. Okay, if I say throws here, does that shouldn't bug anybody. Okay. Make new wrap new able to throw. We don't throw yet. I think I'm going to put the test in first. Okay, much painful as that was the first time. All right, so parser tests. Let's do a wrap new success. I was so happy to have something that seemed to wrap things. I guess I wasn't picky enough. Okay. I don't know if we need the analyzer or not, but we're going to say wrap new. And then I got to give it a new style parser. Okay, do I have something like that? Not really. Okay, so let's make a let's make a little helper function match well, what do I want? If I wrap a new thing, it should look like an old one. So it should return a value of some type. Okay, so if I call match dot plus, okay, I need to make match, function match takes a token type and what did I do here? This one's actually quite adequate. Match return satisfied. Let's just call this match. Okay. We're testing with it. Okay. Analyzer dot match plus. Okay, and we'll learn something from our last experience and put it inside things. Okay, so wrap new analyzer dot match plus. Okay, and then, well, we're just going to call parse on it, so we need some stuff to parse. Excuse me. Okay, so let's say the index is 1, meaning we've read some stuff, we're past token 1 and we're on to token 2. Okay, I should call analyzer match plus dot parse dot parse. Yeah, I mean, I almost want to just do that. And this is not parser, it's result. I don't want to pass tokens in, so that part's wrong. All right. This is irrelevant. Okay. And I should get a success. I should be matching this plus value result. Yep. The value should be token 2. And the remaining should be token 3. Well, no, that's not the way this works. This one, parse should give me a result. That should be a token 2. Result should be token 2. Okay. And index should now be 2. It should move forward. Okay. And this parse, that's just my call to access this thing. Okay. So missing argument, well, wrap new. It takes a parser, it calls parse. Actually, it's going to need the analyzer too, just like the other one. Okay. Let's fix our test. Equals analyzer match parse plus, and our parse method doesn't, it should just return p.target. Okay, we're not doing this nil thing anymore. We're not doing the int thing anymore. Okay. Because we want this thing to do the work. Okay. So it calls the new parser. If this is analyzer.tokens sub index ... So you should parse with your new parser array slice p.input. I may need to restrict p.input equals token. Is that legit? I think so. No exec matches in call to subscript. Well, this is analyzer.index. Okay. So if it succeeds, all right, I gotta get my head straight on which one's which. Okay, if the new parser succeeds, it gets a value in a remaining. It should only return value. Because that's what it does. Okay. But it needs to move forward. Analyzer.index equals that. Okay, so it succeeded, so we need to update the parser to reflect the index it got back. I believe that. Okay. Now the throw, this is where I'm less clear. Failure should be throwing. I forget the name that I used in here. Parse error. Okay. And this is an index. This is failure index and message. Okay. So parser needs a token, which is analyzer.tokens sub failure index and a message. Okay. Parse error dot error. And we're not handling that case right now, so let's just put wrong message. Okay, I'm just trying to get through this case. All right, if it succeeds, it bumps the index forward to the point it picked up at. Okay, that's fine that it's immutable. All right, I think this test should pass. This test that doesn't even build. Can throw, but it's not marked with try. Okay, it should not throw in this case. Oh, everybody else is not happy. Oh, boy. Okay. Wrap new, parse. Okay, I'm going to have to take this out. Oh, we got to pass the analyzer. Statement result equals that if. Okay, let's do this. Well, let's just return this thing. If it works, return it. If it doesn't, catch. What are we going to do? Well, we're actually going to do nothing. I'll just comment it for now. Whoops. Okay, try wrap new. If you get it, return it. If you don't get a statement, just fall through and that stuff will deal with it. Okay, that is the first one. Second one, do return this, try, same deal. And we'll improve this over time. All right. The statement. Okay. Wrap new allocating and it based. Okay, I don't think we need that. Let's run the test. Okay, run this test first. Sorry, my phone's bouncing off the hook here. Okay. Index out of range. 8. Analyze the tokens. Only 6, huh? How did we get up to 8? Okay, integer dim, variable z, parent 6. Sorry, parent. What's the deal? Are we on the right test? let's just run this test. Okay, yeah. That is good. Now, what's going on with the rest of these? Good old right parent error and dim. Okay. Analyzer.tokens only has 6. Okay, so it's 10 dim z left parent 3 end of line end of input. Okay, so why did our failure index get so high? I don't know how it got to 8. Okay, I want to skip this test for a minute. Oh, interesting. Okay. Let's see what tests we're on. Right parent error and dim. Okay. Parser test. There's a way to disable it and run all tests. Okay. We haven't dealt with the failure case yet, so let's test that. Let me make sure we don't forget this one. Re-enable check right or missing. What did I call it? Right parent error and dim. Okay, make an error like a recursive-descent parser does. Okay, and we're doing this. Whoops, too. Okay. Parser tests. I'm surprised the index is wrong, but okay, let's wrap new success. Let's do wrap new failure. Okay, so this time we want to catch it. If we don't catch it, we'll fail. Didn't throw. Got a result. Okay, those aren't the right asserts. All right. Yeah, the heart of it is we're going to call this match plus with something that is not a plus. I don't think we need 3 tokens to do that. Okay. But the token should be token 2. The error token should be this. Since we're starting our index at 1, that's where that is. We've got token 1, token 2. Okay. And the message, what's the match plus, what is the message on match? Well, what's the default message on satisfy type? I think I can give it a message. Yeah, did not find expected value. I think that'll be okay for our test. That seems right to me. The token should be the token that did not match. We get a did not find expected value. If we don't throw, we complain. Okay. This test should fail. It should have the right token, but the wrong message. Okay. We just want to pass the message through here. Want to return back the message we got, but something's wrong. Well, let's run this test, I guess. I think the test should pass, but I don't know why the other thing's not working. Okay. Let's say we did these. I mean, we did. Re-enable test right parend. And now interesting. You can't even tell it's disabled. Oh, there it goes. Okay, and we've got the same thing, right? Index 8. What's the message? Missing right parend. That's good. How did that get so high? Okay, this is in new rep new. Okay. We parsed this. Let's see what analyzer.index is. Analyzer is not a valid. Oh. Analyzer.index is 1. So we called parser.parse with analyzer index 1. Let's look at tokens. Analyzer.tokens. It's only got 6. It's got the line number dim, variable, left parend, right parend. Okay. So why did failure index get to 8? I don't even understand how it gets that far. I mean, I don't think it should be, it could be 5, but it should not be, even not be 6, and certainly not 8. It's like somebody added to it, but okay. A new parser looks like an old one. So success, we reposition it on success. On failure, failure index 8. So it's our new parser somehow got to 8. Well, I guess we'll know where to start tomorrow. I may look at it a little bit just to spare you watching me flail around not knowing what's going on. But the puzzle to me is like failure index should never get that high. And if the parse old, I mean, it's always starting from an index. Yeah, I don't understand. Okay, but that's where we got to pick up. So tomorrow is, let's see, tomorrow's Wednesday. So start at 10 a.m. Eastern time to 12:30 p.m. or 3 to 5:30 p.m. UTC. We've made some progress. We've got the basic, the success case working, but not the failure case. So something. Well, okay. I'm sorry. There's two things going on for sure. One is there's something wrong that the index gets so high. The other is we really need to work out how, kind of from an interoperability point of view. Let's get down to statement. This fall through is not the right way to handle errors. If it got an error, it should report it, and there's a little bit of a thing because the new style is backtracking, and so it's not an error until every possibility fails it. But I think in this case, like this code could be here where dim is. We know it's supposed to be a dim statement, so there's no getting out of the failure there. But all right, we'll figure out next time why that index is off and go from there. Thanks for joining, and I hope to catch you in the future. Take care. Bye-bye.